On what intervals is the function increasing and decreasing, and then concave up and concave down. So all you're doing is you're finding your derivatives, set them equal to 0, and math. So first derivative, you should get 3x squared plus 6x minus 9.
Yep.
Set that equal to 0. If you're not sure how to solve a quadratic, you can always use your quadratic equation or quadratic formula, but I don't think have to do that here. Take out a 3, and then this factors to x plus 3x minus 1. Yeah, I guess if you factor wrong, that ruins everything too, so just take your time doing that.
Yeah.
Set these equal to 0, you should get -3 and -1. So increasing and decreasing, you're going to take some values that are around there, you're plugging those into the first derivative. So like maybe...
Is it a -3 positive one?
Is it? Oh yeah, my bad.
Yeah. Take your time with your...
I know, right? I just said that. Good job. Okay, so that makes it easier actually, because now I can plug in 0. Yeah. I get -9.
You get a negative number, yeah.
If I plug in a really big number, like infinity, I'm going to wind up squaring it. So if I plug in like 100, I'm going to square 100. It's going to be really, really big positive. So this is going to be positive. If I plug in -100, I'm still going to square it. So it's still going to be a really, really big positive. So it's increasing up until -3 and then after 1. So you're going to write increasing from -infinity to -3, union 1 to positive infinity. And make sure you put it in order from smaller to bigger. So don't put these this way. That's weird. And then it's decreasing from -3 to 1.
Take that quiz again. I feel like we'd do better.
You probably would.
Like, I don't think we're clueless.
No, I know you're not clueless.
Yeah.
No, I know.
Yeah. Like, I think but it doesn't matter. We messed it up the first time.
I think you just didn't, like, refresh Tuesday.
Yeah.
And that's what I'm talking about, is, like, if this was pre-calc, you wouldn't do that. You'd be, like, studying Tuesday.
Yeah.
And, like I said, it's just going to get harder. So I'm not, like, too worried right now, but I want you to get into a better habit moving forward. Okay. Now what?
You have to do the second derivative.
Exactly.
6x plus 6 is the second derivative.
Yep. Set that equal to 0.
It's pretty easy.
This is linear.
X is just 1.
-1.
Or -1.
So, -1. So I can plug in like 0, I guess, and I get positive. If I plug in -2, I'm going to get negative. And just remember, you're plugging these into the second derivative. Because it's a second derivative test for concavity versus a first derivative test for increasing and decreasing. Versus just trying to find extrema, that you plug into the original because you're looking for the actual points on the graph. So this is concave down up until -1. And concave up after -1. Ta-da!
So, longer test.
It is pretty long.
But at least, like, we only have to do the
Yeah, you're not doing
decrease
you're
and
not doing everything, yeah.
So it's manageable.
Some of it's bits and pieces. Alright, now, so
like
second question asks for the same stuff, but it's a different type of function, so it's rational. So you still want to make sure that you're finding your first derivative, but for this particular question, if you would like to rewrite this first, you can, like this. And because 5, the numerator, is a constant, you can just use quick, easy chain rule. You don't need product rule. Now, if this was a 5x on top, you can't do that. You shouldn't bother. You should just use the quotient rule. But since it's a constant, when we find our derivative, we can just do -5 times x plus 5 to the -2 power, and then times the derivative of the inside, which is 1.
Will you like be mad if you don't pick that one?
No. I just do it in case if moving forward, if it's like a 2x plus 5, just don't forget. So, and then before you do anything else, like, so before you even set it equal to 0, rewrite it. So that, because you can't do tests with a negative exponent unless you have a calculator. Oops. Talking about the negative exponent that I wrote down. You can't do like a first derivative test with it written that way. So don't try.
I've tried many times.
Yeah, it's awkward. Then you're going to set it equal to 0 and attempt to solve it. And sometimes you can, and sometimes you can't. You can't here, because if you don't have any x's in the numerator, then the denominator is going to wind up canceling when you multiply by it. So
that's one of the things I'm a little bit uneasy about is when you can't solve it.
Basically, if there's x's in the numerator, you'll be able to solve it. Maybe. But if the numerator is maybe like 5x squared plus 1, this is solvable, but it has imaginary solutions, and so you don't do that here because we're graphing, and imaginary numbers do not exist on the coordinate plane.
Yeah. What about when it's
when we test negative 5? Oh, sorry, I interrupted you.
Mm-hmm.
Go ahead.
What about when it's a quadratic, but it doesn't factor? Like there are solutions, but we just.
So that can happen. So if there are, so if it's quadratic and it doesn't factor, and you can get an irrational solution, you need that.
Yeah.
So yeah, you could potentially have critical values that are like the positive and negative square root of 5.
Okay.
And then you would probably round them. So you'd need a calculator.
So when something doesn't factor, should we like?
You should. So usually what I do is I just do the determinant. I do b squared minus 4ac, the discriminant. And then if that's negative, I don't keep going because I can do that quick.
Yeah, it's freaking.
And if it's positive, then I keep going. And I'll go back and do the whole thing. So this is not solvable, but that doesn't mean we don't have critical points.
It's negative 5, right?
Yeah. So you have anywhere the derivative doesn't exist, that is what you're putting in your test. And remember, you're plugging this into the first derivative. So anything, so this is actually going to be negative everywhere because the denominator is always positive because it's squared, and the numerator is always negative, so this is decreasing everywhere. Okay, what's next? Probably say it's decreasing everywhere, I guess.
Yeah.
I'm just gonna do this to save some time, like not increasing, decreasing everywhere. So second derivative. So for the second derivative, I'm probably looking at this before I simplified it, because I can use a chain rule again. So second derivative is gonna be positive 10 times x plus 5 to the negative 3 times the derivative of the inside, which is 1 again. Okay. And rewrite it. Okay. Can you set this equal to 0 and solve?
No.
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 No, because the numerator does not have a variable in it. So that means the only value you put is negative 5. Yeah, basically the asymptote, the vertical one. So the numerator is always positive, which means you're just checking the denominator. Anything less than negative 5 is going to make our denominator negative, which will make it negative. Anything bigger than negative 5 is going to make the denominator positive, which will make the fraction positive. So that means that we are concave up from negative 5 to infinity, and concave down from negative infinity to a negative 5.
I wish we could graph these. It's my favorite part. It's so fun. It's like all this stuff coming together when we have something.
Okay. Next. Yeah, you don't graph these. So it says use the first derivative test to determine if the critical points of blah 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 are relative minima or extrema. So all you're doing is first derivative and the test. And then you're going to identify them if they are.
I like these. That looks fun.
Yeah, those are fun. I put some of those on there. So we got 15x to the fourth minus 60x squared.
Don't we want to factor out like a 15x squared?
Yep. So that's going to give me x squared minus 4.
And then we can factor x squared minus 4.
Yep, because it's a difference of squares.
He's just on a roll.
Whoops. Not 4.
Look at my quiz.
All right, so you should get 0, -2, and 2, because you also just don't forget to set 15x squared equal to 0.
Right.
All right, so first derivative test. Make sure all those numbers are in there.
So like here we have to actually test like -1.
Yeah. So -1, and remember you're plugging it into your derivative. So
That's 15.
15 minus 60 minus.
But it's -1, so then.
I know, but you're squaring it, so it's going to make it positive.
Oh, okay.
So that's
That's
going to be negative, and then positive one's going to be negative for the same reason.
Yeah. And then
But if you do like,
negative infinity is going to be.
yeah, like 100 is going to make it really big, so those will be positive. So like positive 100, negative 100 will be really, really big positive numbers because it's to the fourth power.
Okay.
And that is going to be bigger, since it's exponential, like 100 to the fourth is going to be bigger than 100 squared.
So aren't 2 and -2 critical points?
So, well, they're all critical points, but
Oh, right.
zero is not an extrema. So it's important for the graph, but we don't care about that today. We only care about this guy, who's a maximum, and this guy, who's a minimum. So it says, use the derivative test to determine if the critical points are relative minima or relative maxima. So what you're going to say is you're going to say that x equals -2 is a relative maximum. You're going to say that x equals 2 is a relative minimum. And that's it. You don't need to do anything more than that because it doesn't necessarily ask you to do more than that. It just says, are the critical points, blah, blah, blah. Okay?
Gotcha. Okay.
Okay, now
Oh,
number
that's easy.
4, yeah.
We got it.
Number 4 wants you to use the second derivative test for extrema. So I showed someone this one day. Was it you? I don't know if you were both here. So you're going to find your first derivative to see if we have extrema. But you're going to use the second derivative to see if it's a min or a max. So first just find your first derivative and set it equal to 0. And solve. So it's like kind of similar to the last one in the sense that we have another difference of squares, so we can get
Yeah.
0, 1, and -1.
Yeah.
Now, what you're going to do is don't do anything yet, like don't do a first derivative test, find your second derivative.
12x squared minus 4.
Yep. Okay. So, what you're going to do is take each one of these points and plug it into the second derivative. Oops. So what do you get when you plug in, and all you really care is negative or positive, but, so let me erase these. All you really care is this number negative or is it positive? So is it greater than 0, less than 0, or equal to 0? So if you plug in 0, is it bigger than 0 or less than 0?
Less.
Okay. If you plug in -1, is it greater than 0 or less than 0?
Greater?
Mm-hmm. Yeah, because like 12 minus 4 is bigger than 0. If you plug in 1, is it greater than 0 or less than 0?
Greater.
Yep. Okay, this is the second derivative test for extrema. If it's less than 0, then that implies that 0, comma, if I plug this in, I get 0 is a relative maximum.
But if you plug that in, you get -0, -4.
I plugged it into the original because I'm trying to look for the actual point. So I have a relative maximum.
Dude, that is exactly what we messed up.
I have a relative maximum at 0, 0 because the second derivative is less than 0 when I plug that in. That's what the test says. Okay, it's in the book if you want to like check on that again and whatever. It's also on your vocab, I think.
Are you collecting that?
I was gonna say I'm also gonna collect that tomorrow.
Oh, vocab. Yeah.
Now both of these were greater than 0. Both of these are greater than 0, so that implies that we have -1, -1, and 1, -1 are both relative minima because the second derivative at those values is greater than 0.
Relative.
It means that the second derivative is positive.
So this is kind of like a
So it
formula
goes like-
thing.
It's like concave up, making it a minimum, versus concave down, making it a maximum.
It's like,
Okay, and so you have to, in order to get points for this, because it specifically says use second derivative test, you need to make sure that you're showing this stuff down here. That's the second derivative test. So if you find the points and plug them into the wrong derivative or whatever, you're not getting points. Okay. Sketch graph. Now, yours might all look different, okay, because there's lots of possibilities. What you want to do is mark, so for the first one, figure out where 3 is on your graph and just make it do the things it says. It doesn't really matter like how it's doing those things. So it says decreasing and concave down. So if it's decreasing and concave down, it could be doing this. And then it says increasing and concave up. So it can go like this, maybe. So this is a possibility. Decreasing and concave down. This line is weird. And then at some point at 3, it doesn't matter where, it's going to increase and be concave up. Or wait, increasing. Wait, that's still decreasing. I'm done. Just kidding. Increasing and concave up would be like this way. Whoop. So increasing, concave up. Now this is a weird thing.
Yeah.
They probably, I'm trying to, so it probably wouldn't be that. It probably would be, I'm trying to think. Yeah, but it works, exactly, and that's all that matters. Maybe like, I'm trying to think of like another option, but I don't really care. Did you guys think of anything different?
no.
It could be like more, there could be like maybe,
Lines think alike.
no, yeah. All right, now, f prime is negative. So if f prime is negative, all right, so first I'm going to put -2 and 2 down. So if f prime is negative, what does that mean?
Decreasing.
It means it's decreasing. So it has to decrease until -2, and then it has to decrease again after 2. Then it says f prime is positive. So if f prime is positive, that means that the thing is increasing. So it has to do something like this. It doesn't really matter where it changes, and it doesn't matter about concavity. So I'm going to go like, whoops, too far. That. But it doesn't necessarily have to look like that. But that's a possibility. But it could be like higher or lower, because it doesn't say points, it just says x values.
Alright.
Okay. All right, now 6 is find the absolute max and min. So this is what you guys didn't do so great on the quiz. So we have
It's because we didn't
second
put it back in the
chances.
original,
I
right?
know, yeah.
You should let us like redeem ourselves here.
All right, so what do we do first?
Alright, so you just gotta find the derivative first.
So find the derivative to see if there are more points that are going to contribute to this. So you're going to get,
Yeah.
no, but
It's
they
kinda similar.
they look similar sometimes.
Then set it equal to 0.
Yep.
See, I know
Can you solve this?
Heck yeah.
Yeah.
Absolutely.
X equals -3 and +2. And
So,
then
yay,
then we check if
factors.
that is in the interval,
Yes.
and x
It
equals
is.
2 is, but x equals -3 is not.
Okay.
So we cross off x equals -3.
Now, is there always going to be one that works and one that doesn't?
No, sometimes they both
Sometimes they
don't
both
work,
work.
and then you use 0 and 6.
Yes. So if they both don't work, you use 0 and 6. And if they both do work, then you keep both.
Right.
Okay. So now you're going to take
F of 2.
2, 0,
6.
and 6. And you're plugging those into the original function. And you're going to probably do this
Man, see, I was
with a
closer
calculator.
than not with this.
-7 1/3.
6 is going to be
So
some
1/3 times 6 cubed plus a half.
I did
times
more right on this than wrong.
Yeah.
Like
Of the quiz.
on this specific problem on the quiz. Like I did a lot.
Yeah, you
more
just
right
did this
than
part wrong.
Yeah,
I know.
but like I knew what to do with it.
I think this was like 3 points.
Yeah.
Okay.
It's like pumping a ball out of bounds, man. Does not help.
Just have a great warm up. Step up to the tee. Just the worst warm up I've
Ever had in my life. I played so good. Played my career.
That's
round
funny
of
because
time.
usually, like, as a coach, I pick sometimes the kids that have a really good warm up to, start.
Yeah.
Because, like, if you're having a bad warm up, then you might suck.
Yeah.
Or you might just get all the suck out at warm up. There's
Like,
two ways of looking at
physically and mentally, I was like a 2-year-old.
it. Okay, so let's look at this one.